my first question will be from method you learned. What can have inverse function? What kind of function have inverse? One-to-one. Okay. To have inverse, I need one-to-one function. And it's interesting, we're going to talk about the inverse function of circular functions. Okay, so for circular functions, are they one-to-one for any sine, cosine, tangent? No, none of them are one-to-one functions. But you also remember when you do quadratic, well, in methods, you definitely, the first example you do might be quadratic. How do you find quadratic's inverse? What do you have done first? Like, restrict the domain, like the maximum domain is cut from the turning point, and then left can have inverse, right hand side can have inverse. Or you're not necessarily taking the largest possible domain. You can take only from here to here. That's a one-to-one function, and you can find inverse as well. Okay, so for sine, cosine, like let's think about the sine graph, a basic sine graph. Okay, I'm not going to continue from that side. Okay, that's a sine graph. I can find a lot of part which is one-to-one function, right? I can find a lot of part which is one-to-one function. I can, for example, I can take from this part to this part is one-to-one. I can go from this part to this part is one-to-one. But like, because if everyone take a different domain and then do the inverse, everyone will get different answer. So we give a rule. We like someone before pick a part, like pick a domain, say we just find the inverse by that part of the graph, and that's the one-to-one function we want to use. Just clear that part. So we start from this turning point to this turning point. So that is negative pi over 2, and that is pi over 2. Okay, so we will restrict the domain, but the part of domain we restrict is from negative pi over 2 to pi over 2. When we talk about the inverse function for sine, we only talk about this part of the graph. I know there's a lot of part can be one-to-one function as well, but I'm not going to consider about that part. So the only part we consider is this part. Here is this part. And there is three like important points on this graph. So for this one is negative pi over 2 and negative 1. And this part is 0, 0. Well, my graph is bad. It should be symmetrical, but mine was not. That's pi over 2 to 1. So what's inverse function? If you think about the graphical meaning, what's inverse function? It's a reflection by y equals to x. So it's a reflection by y equals to x. Well, I don't want to, because my graph is really bad over there, I will just show you after we swap the x and y and reflect it by y equals to x, what the final graph looks like. So you swap, you get reflect by y equals to x means you swap the x and swap the y value. So this point becomes 1 pi over 2. This point becomes 0, 0, stay at 0, 0. And this point is negative 1 and pi over 2, negative pi over 2. Okay, so this is your inverse function. This is your inverse function. So after reflect this part, okay, this part of the graph, doing reflect by y equals to x, we have that graph. Well, my one is not really to scale, but if you use calculator to do it, you will have this graph. Sorry? Yeah, you need to know the shape is going, like think about this one. This one is increasing, but increasing a slow, like gradient that way. But for this one, after you reflect it, will increase by a quicker gradient. So you need to know the two case. But if you know the sine one, that's just the opposite for the inverse. So you need to know the case. Yeah, that's important. You can't draw in this way. That's not right. Okay, that's not right. So that's the sine, original sine. So the inverse function must be increasing quickly, like going that direction. Okay, so that's the basic shape. You need to remember this shape. Okay, you need to remember this shape. Okay, so that's the sine one. There's 3 points you must remember. So the only thing I want you to remember is this 3 points. Okay, it's this 3 points. So I will use those 3 points to sketch all the sine inverse graph. Okay, if you can remember that 3 points, that's it. If you can remember the 3 points plus the shape, fantastic. You know how to sketch your graph. Okay, that's the 3 points. So the domain. Now we talk about the domain of the sine inverse x. So the domain of sine inverse x is -1 to 1. Okay, that's really important. What you can put into that bracket is -1 to 1. And the range of sine inverse x, well, I think it's all on your notes. I'm just repeat it again. The range of your sine inverse x is from negative power over 2 to power over 2. Okay, so doesn't matter what you put into a sine inverse, you can only get angle between negative power over 2 to power over 2. And another thing is you need to understand the operation like for sine and cosine. Think about what you have done for sine. Sine is when you put the angle into sine, you get a ratio out. So sine means the opposite over adjacent hypotenuse if you think about right angle triangle. So if you insert numbers in and you get ratios out. But for sine inverse, what you put into sine inverse is you put ratio in and you get angle out. Okay, you put a ratio in and you get the angle out. So you put sine inverse 1 means the ratio is 1 to 1, so you get the angle pound 2 out. So if you put ratio sine inverse a half in, the ratio is half, you get 30-degree pound 6 out. So the two operations that you put different things and you get different things out. So actually sine inverse x overall, this thing represent angles. Okay, so what you put in is definitely ratios, and you definitely get out for angles. So actually, the whole expression means the angle. What angle is that? I don't know. Like because, for example, if you put sine inverse a quarter, I don't know what's the exact value for sine inverse a quarter, but that's the angle. The answer must be an angle. So that's really, really important because we need that for later on, like questions. Okay, so after talk about sine, if you go to, well, this is all explanations, okay? I just make it really detailed for you to read if you forget like one day, but I don't really need to repeat everything because I show you everything on this graph. So if you can go to the next page, we think about similar things for cosine. So for cosine, that's cosine x. So sketch a graph for cosine x. Okay, that's a graph for cosine x, for instance. Not symmetrical again. So part of the cosine x graph. In this question, I can't take negative pound 2 to pound 2. Why? I can't restrict my domain negative pound 2 to pound 2. It's not 1 to 1, it's many to 1, right? It's many to 1. If you draw horizontal, it's many to 1. So in this case, what we will restrict is from this point, 0 to this point. I want this part of the graph. Okay, it's a decreasing graph. So the 3 point I just remember 0, 1, pi on 2, 0, and we have pi -1. Okay, we'll reflect this part of the graph. Okay, we'll reflect this part of the graph. This graph is very similar to a sine graph. Okay, this graph is very similar to a sine graph. So that's a cosine inverse. Okay, reflect that part of the graph. So -1 pi is the first point is to remember, 0, pi on 2, and 1, 0. same shape, okay, still that kind of quickly increasing shape, and it's kind of a reflection and translation compared to sine inverse. Very similar, okay, so same, almost the same shape, but at 3 different points. Okay, so minus 1 pi, so reflect that one, 0.2 reflect that one, and 1, 0 reflect that one. Okay, so it's a decreasing function as well, because the original cos is decreasing, and after reflection is decreasing as well. I will show you how to sketch the more complex one, but that's, you need to remember first. Okay, so the basic shape and the basic 3 points. Okay, the original, most original 3 points, that's the 3 points we have. Okay, what's the domain for this question? Yes, same, -1 to 1. What you can put is a ratio, and cosine ratio can only be -1 to 1. And what's the range? 0 to pi. Okay, the angle you put in is only from 0 to pi, and the angle you can get out from it is only 0 to pi. Again, cosine inverse x, that represent angles. Okay, that the whole expression is angle. Okay, it's an angle. Doesn't matter what ratio you put in. 3/5 is not the exact value you can get out, but it still means that's an angle. Okay, so cosine inverse, sine inverse, tan inverse, they are all angles. Okay. Any questions? Okay, same, we go to the next page. Well, tan is kind of easy to think about. If you think about tan graph, well, very obvious, I'm going to take one period. Okay, I'm going to take one period, but which period are you going to take? We'll take the 2 periods closest to 0. The 2 asymptotes closest to 0. So this one and this one. So x equals to -2 and x equals to 2. Tan is an increasing graph or decreasing graph? Increasing. How about cot? Original cot? Decreasing graph. Okay, so that's my tan graph. 3 key features we need to remember. We don't have another 2 points, but we have 2 asymptotes. So the 3 key features on tan inverse graph is the 2 asymptotes and the point of it. It's not really a point of inflection, but this point. Okay, so this point. It's not a stationary point. I can say it's a point of inflection. It's not a stationary point of inflection, but I can say it's a point of inflection maybe. This point is the special point. So let's think about the tan inverse. So what's after reflect by y equals to x? What's the vertical asymptotes will become? Horizontal one, right? So y equals to that. So first let's get to horizontal. So y equals to pi on 2 and y equals to minus pi on 2. 0 and 0 still stay as 0, 0. Original graph is increasing function. So after reflection, it's still increasing. After do the inverse, it's still increasing. So tan inverse is an increasing function. Okay, tan is an increasing, tan inverse is an increasing, and cot is decreasing. Original one. Okay, I'm talking about the most original one. So tan is increasing, tan inverse is increasing, and cot is decreasing. Okay, this point is 0, 0. So the 3, each graph, you need to remember the shape and 3 key features. So for sine inverse and cos inverse, that's the 3 points. Each one, you need to remember 3 points. For tangent inverse, what you need to remember is the 2 asymptotes and the point, okay, the middle point, kind of the point of inflection, so the 0, 0. So what's the domain of tan inverse? R, because the range was R for tan. And what's the range for tan inverse? Inclusive or exclusive? Exclusive, because that's the asymptotes. So the domain, the range is similar to sine inverse, but it's exclusive the negative power 2. Okay, so domain of sine and cosine inverse is -1 to 1. But the range for cos inverse is 0 to pi. For sine inverse is -2 to pi 2. And for this one, it's the same, but exclusive. What my suggestion is, what you need to remember is the most original sine, cosine, and tan graph. Which part of the graph you taken? That's like if you can remember the after reflection one, you can remember the most original sine, cosine, and tan. Which part is the part like I take? And you definitely can find 3 points on that graph. And you can find the swap x and y. You can find the point on the inverse function. So it's actually all connecting to the sine, cosine, and tan graph. Okay. So, well, that's our table. We talked about the summary. We don't really mind for that. The properties, we will come back to this. It's very important. I'm going to talk about that later. When we talk about the calculations. But now I'm talking about the graphs. Okay, I also talk about the graphs. So the way how I'm going to sketch is using transformation. Okay, mapping method of transformation to sketch this graph. So I'll just introduce that a little bit. I think we can pick up really quickly because everyone has learned transformation. So let's think about my original graph. Now I'm going to sketch a sine inverse graph. So what we have is y equals to sine inverse x. That's my most original graph. Okay, so this graph is my base graph. And now I'm going to sketch, transfer from this graph to a new graph. That's y dash equals to sine inverse 2x dash minus 3 plus power 2. Okay, that's the mapping method. I put a dash on the graph I actually want to sketch because it's transferred from the sine inverse to this graph. Okay, I want to see what kind of transformation has been applied to this graph compared to my original one. Okay, as you know, well, if you know mapping, that will be much easier. But if you don't know, that's fine. I will rearrange this. Only keep the sine inverse. I will say that's the house. Okay, that's sine inverse. That's the house, and the 2x minus 3 is who lives in the house. The 2 and the pound 2, they are flowers. Something you need to move to the other side. I want to see my root, this house on one side. So what I'll do is y dash minus pi over 2 divided by 2 equals to sine inverse 2x dash minus 3. While the other side is still looks the same. Okay, now two sides looks identical now. Okay, two sides looks identical because it's y something equals to sine inverse something. Basic is rearranging. The basic rule to keep how to rearrange is just keep the sine inverse, cos inverse, and tan inverse on one side, all the other stuff to the other side. And remember another thing, x and y is your old point, original one, and new one is x dash and y dash. I want to discuss the relationship between your new point and your old point. Okay, that's what I want to talk about. So what I'll do is y equals to y dash minus pound 2 over 2, equalize them, and x equals to 2x dash minus 3. Okay, equalize them. I want to talk about, I will set up a connection between the original points and the new points. And the next step, okay, you must remember the step because you need to rearrange the equation to make y dash and x dash to be the subject. Because I know what my old point will be, but I want to know what's my new point. I want the new point equals to old point to do something with the old point. So y dash equals to 2y plus pound 2, and x dash equals to x plus 3 divided by 2. Okay, after step, it's very happy step. Why I said that? Okay, draw a table like this. Okay, anyone remember from left to right, what's the 3 points on sine inverse graph? -1, -1, -pound 2, 0, 0, and 1. pound 2. Okay, that's the old point. That's the old x and y. That's on your sine inverse graph. That's the old point. So what's your new point? Your x dash is x plus 3 over 2. And your new y is 2y plus pi over 2. Okay, if you sub -1 into the x, what do you get? If you sub y into x, here. Really? -1. 1. -1 plus 3, 2. 2 divided by 2, 1. Okay. 0, 0, 0. 3 over 2. And if you sub 1, 2. That's 2. Okay, you sub all these x. Well, x dash equals to x doing that. Y dash equals to y doing that. So you sub all these x into the rule and see what's the new point becomes. And how about the other one? If you sub y, what's the y becomes for the first one? Negative pound 2. And put 0, pi on 2, and if put pi on 2, 3 pi on 2. Right? Right? Yes, yes, yes. So the new 3 new coordinates becomes 1 negative pi on 2. Let's find where's 1 negative pi on 2. Okay. Next one is 3 over 2 pi on 2. 3 over 2 pi on 2 is here. And 2, 3 pi over 2. And just remember the shape. What's the shape? It's kind of that, right? So you just, that's the only way we can connect it. Otherwise, how we can connect it? There's no other way we can connect that 3 points. And that's the only way to sketch this graph. So yes, you need to find this intercept. Well, that's the method I use all the time because you can definitely make sure you do the correct thing. Well, if you not rearrange or substitute wrong thing, definitely get the correct answer. Or you can just think about transformation. The graph has been reflected that, like, I think it's even slower compared to this method. Or you can think about dilation by 2. So -1 and -4 and dilate by 2 times. So -2 and 2 and then reflect. So I don't know which way you prefer. That point is sorry, what's that? 3 over 2 comma 2. And how do we find x-intercept? Stepping y equals to 0. So we have 0 equals to 2 sine inverse 2x minus 3 plus pound 2. So minus pi on 4 equals to sine inverse 2x minus 3. 2x minus 3 equals to sine pi minus pound 4. What's sine minus pound 4? Minus 1 over root 2. So I will make that equal root 2 over 2. So same thing, rationalize. And then 2x equals to 6 over 2 minus root 2 over 2 plus the 3. And then times a half. That's 6 minus root 2 over 4, which is that point. What's the domain for this graph? 1, 2, 2 inclusive. And what's the range? Yep. See, like, I like to sketch the graph and then think about the domain, think about the range. I don't like to look at the function and say, oh, dilation by that, and then reflect by that, and then move out by that. Like it's a lot of things to think about. I just rather get the graph done and look from the graph what we have on the graph. Okay, that's just a way like I prefer. If you have other ways you think is quicker, you can show me or show to the class. I do circular functions like about 10 years, like in this method. Okay, cosine inverse. Okay, everyone. Come on, we have two graphs to sketch. Rearrange it, only leave cosine inverse on one side. We get like when you know what you're trying to do, like it's really quick. Next step will be equalize y equals to y dash plus pi over 3 divided by 2 and x equals to 1 minus 4x dash, because the original graph is cosine inverse x, y equals to cosine inverse x. So equalize the left hand side, equalize the right hand side bracket, not including the cosine inverse, just whatever you put in the bracket. So what we will have is y dash equals to 2y minus pi over 3 and 4x dash. So x dash equals to 1 minus x over 4. Move the 4 that side and move the x the other side and divide by 4. Okay, after you find the relationship between the new point and the old point, we sketch the table. So we have x dash equals to 1 minus x divided by 4. And we have y dash equals to 2y minus pi 3. Let's think from left to right. What's the 3 point you have on cosine inverse? Negative 1 what? Negative 1 pi and 0, 2, and last one 1, 0. Okay, let's do the x substitution first. When you sub -1, what do you get? Half. Sub 0, quarter, and sub 1, 0. How about y? 5 pi 3. Next one, 2 pi 3. And the last one is negative pi 3. Like why I like this method, because you don't need to use your brain much. You just do the rearrangement and just rearrange. You just remember, okay, I want to rearrange x dash and y dash and just have values in. You don't need to think that much. Oh, what's the dilation? What's the reflection? What my graph finally looks like? You just put the 3 points in and you can see. So a half and 5 pi over 3, where is it? So half 5 pi over 3 is here. Okay, so that's here. A quarter 2 pi over 3. And 0 negative pi over 3. Think about the shape of the graph. And I can see x-intercepts there. So I need to solve for that. Or you can solve x intercept by yourself and just check with me. Well, if I go too fast today, you can just go back to look at the notes again. It's very detailed, like working steps here. You can try to do that again by yourself. You don't need to get all the notes done on class because I know I write pretty fast, but I really need to get this done. So if you miss any part, just go back to the notes on OneNote and you can just try that again. Okay, if you finish the cosine inverse one, can you try to think about the transformation for the tan inverse? Okay, think about the transformation for the tan inverse. So what kind of transformation are you trying to do? And set up the tables. I just suddenly remember that now. Which function looks like a blazer? Make him to think about the blazer. We finished cosine inverse? Yep. Okay, so for tan inverse, pi minus y over 4 equals to tan, well, y dash tan inverse x dash over 3 plus 2. Now move the 4 tan inverse to the side and then move minus y to the other side and divide by 4. So y equals to y minus y dash over 4, x equals to x dash over 3 plus 2. Tan is near one extra step, so we'll talk about that. Still doing the same thing here. Y dash equals to pi minus 4y, and times 3 is 3x equals to x dash plus 6, x dash equals to 3x minus 6. Dash equals to 3x minus 6, y dash equals to pi minus 4y. Okay, what's the three key features of tan inverse? Origin, y equals to pound 2. Yeah, y equals to minus pound 2. Thank you. So when we talk about the tan, we don't talk about those two x because there's no x component involved. Because it's only y get involved, like for the asymptotes. So if you think about 0, 0, I will have minus 6 and pi here. And if you sub y equals to minus pound 2 in that, that's 3 pi. I think that's minus pi. So it's y equals to 3 pi and y equals to minus pi. And minus 6 and pi is here. All right, tan need extra step, tan inverse. So if it's tan inverse positive x or negative tan inverse negative x, like both negative or both positive inside and outside, the graph is an increasing graph. So it's increasing graph in this case. If one of these is negative, or same as the cot and tan, how you sketch it. So if both one of them are negative, you will have decreasing graphs. Okay, so when you know the asymptotes, you know the middle point, like you need to think about the shape. So in this question, what's the shape? Positive or negative? Negative. So that's kind of like that. Well, this, I should move the y-axis a little bit to the right-hand side. Can you see x-y intercept? Is there x-y intercept? Yes. So I need to find x-y intercept. So the y-intercept is easy. That's 0, pi minus 4 tan inverse 2. That's it. That's the exact form. Just sub x equals to 0 in. I can't do much about it. What's tan inverse 2? I don't know that. Now you can sub y equals to 0. So 0 equals to pi minus 4 tan inverse x divided by 3 plus 2. Is that plus 2? Yes, plus 2. So what we have is tan inverse that equals to pi over 4 and x over 3 plus 2 equals to 10 pi over 4. What's 10 power 4? 1. So x over 3 is minus 1. So that's 1. That's minus 1. X equals to minus 3. That's a good value. So it's minus 3. Well, so see, I'm not really plot on the right point. So negative 4 is here, negative 3 is kind of here. Negative 3 comma 0. So I need to adjust my graph a little bit. Okay, what's the domain for this question? Last question. Domain R. Range. What's range? Thank you. Negative pi to 3 pi. Okay, in between the two asymptotes, but not taking asymptotes. All right. That's it. I'll just stop here. Very good. We finished the 3 graphs, and next lesson we'll talk about some calculations for sine inverse and cos inverse, tan inverse. Okay. Quiz on Monday. We'll have sine inverse in it. Okay, we'll have sine inverse in it. Yeah.